This particular column ran less than 18 months and failed. Loss of containment, it shut the unit down. And just so that you have kind of a general picture of the geometry, here's the column, support ring. The portion of the column that we're going to talk about here is down in the bottom. This is the steam sparging nozzle, and we're going to talk about one of these 2-inch nozzles that's on the opposite side. And here in the detail, if you can read it, we noted that the weeping was noted underneath this nozzle. Again, flued nozzle construction, I think by now everybody's fairly familiar with that, where the lining is flued out for the nozzle connection, and then a butt weld is made. So what happened with this column, if you look at this component here, it's laying down obviously, but this is the top flange and this is the bottom flange. And this is the steam sparger nozzle, and the weeping was observed here. There's a repair putty there as the plant tried to control the situation so that they could quickly get the plant shut down. This is after we did some grinding and we're starting to see what's going on, and the weeping was coming out from under the reinforcement pad. So then we started cutting things up, and what we observed quickly was that there was, if we see this as the nozzle right here, this is the shell wall. Here, this is the lining on the inside, and this is the attachment and reinforcing overlay for that nozzle. There was clearly a chemical attack of the FRP at that interface right there, and weeping occurred there. We also noticed a pretty big crack, separation of the nozzle lining and the shell lining at the weld line. So I've captured, I think, several of these already. What we saw initially was significant lack of fusion, and in fact, this sample, which I'll pass around again, that I have here, this is nozzle. This is the smaller nozzle. This is the 2-inch nozzle, and I think it was N4. Yeah. 2-inch N4, and spark testing of other nozzles, N4 and N9, found continuity breakthroughs, and the column was spark tested initially, so it passed initial spark tests. And you remember we've talked a lot about how spark testing may not be the end-all be-all in terms of determining flaws, catching flaws, if they aren't significant enough for the spark to jump fully through the cross-section, and we'll see that was a factor here too. So again, this is the cross-section you've seen a couple of times. The things that I want to draw your attention to is this is N4, okay? And this is the one that I have here. We talked about the big variation in root gap, approximately 3 mm. Significant lack of penetration fusion. What you see back here behind the weld is the weld nugget. So the weld nugget is, in essence, sitting on top of the butt joint, the square butt right there. But once we cut this up, we started seeing, hey, there's more stuff here that we really need to pay attention to. First of all, I don't know if you can see it, but there's conductive target material out here well away